So from the coordinates of the last point on this new plan that we have made, we can see that although we don't hit the target exactly on the north and east, we do hit it exactly on vertical depth and vertical section, which is adequate at this point. So I continue from here and go to options and I go to file and I will save this plan that I have made and I'm going to call it plan B appropriately. Plan B. Make plan B the current well no. So here we are back at demo. I have saved the plan that I made. I called it plan B. And I'm back demo and I have a projection that takes me 2026, which is the drain entry point. So at this point, I'm going to put all the things that I have done with the program together and get the one information which is most important, and it's the end result of all of this, which is how much and in what tool phase direction should I slide on the next stand. Okay, so to do that, first of all, I have to get back to the bottom of the hole. So I will go get back to this screen which shows it all, and here you have this delete button, and this delete button deletes one station at a time from the bottom of the projection. So here I am at 1882, 66.98, and 70.15, bottom of the hole. So I continue from here, and so I project from projection, and I will go to the Ouija board again and go to slide, but this time there is this option here, which I haven't used yet, which is next. So, and it will be calc next slide course length. So I go next here. These are the default inclination calculated. Of course, we don't know if it's exactly right, but calculated inclination and azimuth at bottom right now. We could change it if we wanted to, but we don't, and we leave it. Okay. Then the next Kelly length is 29 meters long, and we leave that. It's okay. The dog leg is what the program calculates based on the surveys and the slide intervals, 8.36, and we leave that. It's okay. And rotating build-up rate is 0. Inclination increase or decrease from bottom projection after drilling 29 meters. So we know we want 4.2 in 30 meters. So in 4.2 in 29 meters is going to be 4.2 times 29 divided by 30. 29 space times space 30 space divide. And the desired turn, we are going to say we want to go a full 3 degrees to the right of the next Kelly. And here we go with the result. The desired build turns out to be 4.1. The desired turn is 3 degrees right. The next TD is at 1911. Inclination 71, azimuth 73.1, and the next Kelly slides 17.7 meters with a tool phase of 35 right. So this, as you can see from the existence of the append button here, this is a projection as well. So you can go append, then you can go to options again, and then we can see where this will be relative to both plans. So first thing we have to do is we have to choose plan B also, and in the original plan we're going to leave it as chosen as well, and we're going to calculate. As you can see, it went through the calculations very fast. And so now we're going to check the review button. So from demo to plant B, we see that we're spot on the plan, on the above or below, it's spot on. And we're 0.3 meters left of plan, and I'll leave it to your homework tonight to figure out why it's not exactly right, and because that 0.3 is correct. So we continue here, and here we see the comparison of the curvatures, and you can see that dog leg with that the original dogleg is 4.2, and to get the turn additionally, the dogleg goes up to 5.1, which is still okay. And then here we are comparing with the original plan, and you see we're lagging the plan by 1.4. Before we were lagging the plan by 1.3, now we're lagging the plan by 1.4, and we are getting closer to the plan. Before it was 3 something, now it's 2.4. So, and here we have the comparison of the build-up rates, and that's it. So I return to the survey menu here, and we are 1863. That's our last survey. And so we know we're going to fly what's almost 18 meters in two phase about 35 right, which makes kind of sense. And that should put our well in a pretty good position. So we see how we have calculated the survey, calculated the survey at the bottom of the hole, then compared that bottom hole location with the plan, calculated how much we should slide on the next stand in order to make the target at the desired TVD and vertical section.